Okay, welcome to this video where I'm going to go over the third page of the study guide. I'm going to start with number 13 here. Jessica's pet rabbit weighs 45 pounds. Jessica puts the rabbit on a diet and he loses 2 pounds per week. So create a model that describes the relationship between the rabbit's weight in the weeks past. Define your variables. Well, the rabbit is losing the same amount each week. So I know this is a linear function. And so linear functions are y equals mx plus b, where b is the beginning, right? This rabbit began at 45 pounds, and it's losing 2 pounds per week. So I could say, write that as a math expression. And so I'm going to plug 45 here into b, and I'm going to plug a -2 into m since that's the constant rate of change. And I'm going to use some different variables. I'm going to use an r for rabbit equals -2 pounds per week. I'm going to use weeks plus 45. And now it says define your variable. So I just told you what mine mean, but I'm going to write it out now. R is equal to the weight of the rabbit, right? And W equals weeks on diet. Okay, so he's losing 2 pounds every week. Okay, so how many weeks will it take the rabbit to have a weight of 33 pounds? Well, now I can use the model that I created to find this answer. R represents the weight of the rabbit, so this 33 just goes into the R. I'm going to plug in a 33, and I get -2W plus 45. So I plug in the 33, and it says how many weeks? That's my unknown, how many weeks, which makes sense because I have a W right here, right? There's a W right there that represents an unknown amount of weeks. We have to solve for the answer. I'm going to solve this two-step equation. I subtract 45 from both sides. These cancel. I get -12 equals -2W. Divide each side by -2. We get W equals 6. So after 6 weeks, the rabbit will have a weight of 33 pounds. Now, I'm gonna erase this real quick. So if you need it, you might need to pause and rewind the video. But there's another way you could have done this. You could have made a table that showed the relationship. So here we have weeks and the weight of the rabbit. At 0 weeks, we know the rabbit weighs 45 pounds. At 1 week, he's losing 2 pounds per week, 43. 2 weeks, 41. 3 weeks, I'm going down 2 each time, right? 39. 4 weeks, 37. 5 weeks, 35. 6 weeks, 33. Look, just like we found in the equation. After 6 weeks, the rabbit will weigh 33 pounds. And so that's another way you could do that. Again, if we do our math correct, there's a bunch of different ways to get it right. All right, the function g is shown on the chart below. Create an equation that represents the table. So right away, I'm looking to see if this is linear. Linear is a constant rate of change. So this goes up 5, up 5, up 5. This is up 1, up 1, up 1. So yeah, it looks pretty good. This is linear. So I know I'm going to use the equation y equals mx plus b. And we're going to, I guess we have the g of x here, which is representing y. So I can g of x. M is the change in y over the change in x. So m equals the change in y over the change in x. Y is changing by 5 each time. X is changing by 1. And so the slope here is 5. X is a constant, and B is the y-intercept. B is the y-intercept, right? It's important to point out that the y-intercept is always the value of x, always the value of y when x is equal to 0. It's not just the top number, so it's not 7 here, right? Many times we start at 0. This didn't, it started at -1. But the value of y when x is 0 is 12. And so my b is 12. And so we get the g of x is equal to 5x plus 12. All right, a local river is drying up. The graph shows the relationship between the river's water level, L, in the number of weeks W since measurement began. Create an equation and table that represent this relationship. Okay, so I'm going to start with the story. All right, what do I notice here? I notice that this river starts at 20 feet high. And how much is it going down? It looks like it's going down right here. I have a point. It looks like it's going down 2 feet every week, right? After 1 week, it's 18. After 2 weeks, it's 16. So I could plug those right into the table if I wanted to, right? These are points on the graph. So I'm going to say the weeks and the feet. At 0 weeks, it's 20 feet, right? That's a point on this graph. 0 weeks, 20 feet. At 1 week, it's 18. At 2 weeks, it's 16. So I could make the table first. And that really makes the rest of it easier, right? I can tell a story here. A river begins 20 feet deep. Well, what's happening each week? It shrinks, or decreases probably would have been a better word. It shrinks 2 feet per week, right? So this graph told me that information, right? This table shows me that same information. This story tells me the same information. And I can write an equation, I'll do it in blue so you can see it clear, that tells me that same information, right? I could say the feet of the river is equal to, actually, let me say the f of w, so function notation. So the input, the amount of weeks, well, it began at 20 and it goes, why did I do plus? It goes down 2 feet per week, right? So this equation tells the same story. The height of the river in feet is equal to 20 minus 2w, because it loses 2 feet per week. So this graph, this story, this equation, this table, all show the exact same thing in a different way. Okay. The announcements are about to start here at Forest Park, and I don't want them to interrupt this video, so I'm going to go through this a little bit quickly. Create a story, equation, and table that could represent this graph. I'm going to start with the equation. I know this is a linear function because y, it's a straight line. So I'm going to use y equals mx plus b. I'm going to start here at b is -2, right? And the slope is equal to the change in y over the change in x. So it looks like we go up 2, change in y is 2, over 1, 2, 3, over 3. So the slope is 2/3, and so my equation could be y equals 2/3 x minus 2. So I'm going to erase that real quick, just to give myself some more space. Y equals 2/3 x minus 2. And now I'm going to write a story. The story should begin at -2, and it should be changing by 2/3. So I could say, I have $2 in debt because it's starting at -2. I could say I gain 2/3 $1 or $2 every 3 days. All right. And now I can use the points on the line to make my table if I don't want to add by 2/3 each time. And so I'll make the table here in black. I have x and y. This first point right here, what's the value of x? It's 0. And the value of y is -2. Remember, the y-intercept is always when x is 0. That's why this point is 0. Then I have another point here. The value of x is 3, and the value of y is 0. That's called the x-intercept. And then I have another point here where the value of x is 6, and the value of y is 2. Okay, that is it for this page of the study guide. Lastly, we have the last page, which will be the next video.